So lipids. So lipids also can serve as structural molecules. And we'll talk about that a little bit today, but we'll really get into that when we talk about membranes in a subsequent chapter. And lipids also serve as energy storage molecules. In some ways, lipids are superior as energy storage molecules because they can be more compact. And the reason they are more compact than compared to carbohydrates is because on a per atom basis, the lipids hold more energy. And this is because the lipids have fewer oxygen atoms associated with them. And also lipids, they're defined as molecules that don't interact with water well. So you know the idea that oil and water don't mix, which is kind of what's being shown right here. They don't mix because the lipids don't have a lot of polar bonds in them. And so they don't have a lot of oxygen, basically. And they instead have a lot of carbons and hydrogens, and this makes an oil-like substance or a lipid-like substance. And these are defined as things that don't like to interact with water very well. So when you put a lipid and you mix it with water, the lipids kind of segregate and bunch together so that they're far away from the water. And this also helps lipids as an energy storage molecule because with the carbohydrates, not only do you have less storage per atom in the carbohydrates, but you also have lots of water clinging to those molecules. Whereas with the lipids, they form into these fat droplets. And so lipids, as a consequence, not only are full of energy in and of themselves, but they also are very compact because they don't have a lot of water hanging around with them. So the next step of talking about macromolecules is to talk about the lipids. So lipids come in a great variety. So the defining characteristic of lipids is that they are hydrophobic. They tend not to interact with water well. They tend to run away from water. When you say oil and water don't mix, what happens is you put oil onto water, and the oil tends to congeal into or congregate into a single droplet. This is the water trying to get as far. This is the oil trying to get as far away from the water as possible. That actually, the way I inadvertently said it, works as well. It's also the water trying to get as far away from the lipid as possible. But here's a whole lot of different names for things that are basically lipids. We've talked about fatty acids and fats a little bit, and we have all sorts of different kinds of fatty acids. Triacylglycerol is another name for a fat, as is triglyceride. We have saturated fatty acids, which it refers to the amount of hydrogens that are associated with these fatty acids. And we'll show pictures of that. And unsaturated fatty acids actually have fewer hydrogens. So they're not as saturated with hydrogens. That's why they're called unsaturated. We can have varying degrees of saturation. So monounsaturated is less unsaturated than polyunsaturated is. We also have these crazy things called trans fats, which is a human invention. These are other kinds of fatty acids. And oil is basically a fat that's a liquid at room temperature. Phospholipids are structural molecules. They're the molecules that make up membranes, as we'll get to in a subsequent chapter. And these are a kind of phospholipid. A steroid looks nothing like the fats, but it shares with the fats this propensity to run away from water. Cholesterol actually is a steroid-like molecule, but there are also lots of steroid hormones. So we have various sex hormones, testosterone, estrogen. These are lipids, and they're based upon a very distinctive ring structure that you also see with cholesterol. Waxes are lipids. Lard is a lipid. If you're talking about omega-3 fatty acid, those are lipids. Free fatty acids. The salt form of free fatty acids we call soap. In fact, that's how you make soap. You start with fats. You break apart the fat into the fatty acids plus the glycerol. And in doing so, you replace a hydrogen with a metal ion like sodium or potassium, and you have soap. Butter is predominantly lipids, as is margarine, olive oil as well. My favorite flaxseed oil. I should start taking that again. Toasted sesame oil. I love toasted sesame oil. These are all lipids. Bile salts are lipids. In fact, they're detergents. They're involved in the digestion of food because they have a part of them that wants to interact with the lipid part. It's hydrophobic. And another part that wants to interact with water. And so they're able to break up big blobs of fats into smaller blobs of fat to which enzymes can reach to break down the lipids during digestion. Vegetable shortening, hydrogenated vegetable shortening, partially hydrogenated vegetable shortening. These are all lipids. These various kinds of structures don't necessarily share a common core structure like we saw with carbohydrates and we saw with the proteins, and we'll also see with the nucleic acids. What they have in common is this hydrophobicity. So the hydro part is reference to water, and phobic means hating. So lipids are water-hating. Maybe not over their entirety, but the bulk of their structure does not want to interact with water very well. And lipids also tend to be hydrocarbon-like. So what's a hydrocarbon? It consists of hydrogen and carbon. It's nice when the words actually make sense. And so when you look at lipids, you're going to see a lot of carbons and a lot of hydrogens. And those carbon to hydrogen bonds and also carbon to carbon bonds contain energy, much more energy than a carbon to oxygen or hydrogen to oxygen bond does. So we saw a lot of the carbon to oxygen and hydrogen to oxygen bonds in carbohydrates. You're going to see much less of that when you look at the lipids.